In this video, I will show you how you can perform a linear regression using SPSS. So first of all, let's have a look at our data. The dependent or outcome variable here is birth weight. You'll see that these data are continuous. So for a linear regression, our outcome has to be linear, but all of our other independent variables, they ideally should be linear, but they can also be categorical as long as they have just two categories. You can also create another type of category where, for example, if you had three, let's say eye colour, that you would have blue eyes are 1 and all other eye colours are 0. You would have another column green eyes are 1 and all other columns are 0, and another column where brown eyes are 1 and all other columns are 0. So there are ways of doing it. So in order to perform the regression, we go here to Analyze, and then we go to Regression, across to Linear. The first thing to note is that we want to use the method enter. So we leave this as the default, but make sure that it does say enter. Then we put our outcome or our dependent variable in here. So in this case, we want the weight of the baby at birth. So we're going to just move that over. And then we want to select other independent variables which we think might have an effect. So for example, we will select gestation period, the length of the baby at birth, maternal height, father's age, and also the height of the father. Now, there are lots of other settings here. Quite a few of them will be part of the analysis to look at meeting assumptions. There's a separate video for looking at the assumptions, but I will tick some of these options as we perform this analysis here, but I just won't describe them in too much detail. So first of all, we would go to the statistics button here, and we would make sure that model fit is ticked, which it is here. We're then going to tick R-square change. You might find it useful to tick descriptives and also part and partial correlations as well. Okay, and then we'll press continue. Next, we're going to go to plots, and here what we're going to do is we're going to put the residuals, the standardized residuals, and we're going to plot them against the standardized predictors. So the standardized residuals are a little asterisk Z, R, E, S, I, D. This one here, and that goes over there into the Y, and then into the Z we want the standard predicted ones. So that's actually just above it here, and that goes into this, and that will then allow us to look at our residuals. Click continue. Then we'll go to save. Quite a few different options here. So you may be interested in ticking Cook's distances here. There's a few other options that may be relevant if you need them. And then we also want unstandardized residuals. This will allow us to perform some other tests as well. And then press continue. And then we will press OK. So several tables will be produced, and some of these just give you a basic summary of information. For example, here this works out the means for some of our data and also tells you how many samples are included. This might be useful as part of your write-up. We've then got our correlation table. This is important in the assumptions. This is how you can check that none of the variables are too highly correlated with each other. But as I say, all of that is mentioned in the other video talking about testing assumptions. So for actually doing the analysis, let's assume that we've met our assumptions. So these are the tables that we're going to be most interested in, these three tables. So first of all, the model summary. So this is really telling us how much variation in the dependent variable, in this case birth weight, is actually due to the predictors. In other words, the independent variables. So we can see here by looking at the R square that this is actually representing about 63.7 amount of the variation in birth weight can be attributed to our predictor variables. The reason that this hasn't changed here under R square change is because we've only had the one model. If you were doing hierarchical regression, then you would have more than one model and this value would change. So that's why you have the same value here at the moment. However, every time you add a variable, R square increases, even if that variable isn't really having an effect on the model. So if you have a small sample size, or if you have lots of variables, you're much better to use adjusted R square. So this just compensates for that. So actually it looks like 58.6% of the variation in our dependent variable is or can be explained by our independent variables. And we also have a p-value here, sig f change. So if the model is significant, i.e. if the relationship between the dependent and the independent variable is significant, then this will be less or equal to 0.05. And it is here, so this all suggests that the model fits pretty well. If we move on to the ANOVA table, here you'll see that we have a row for regression and under the sum of squares here. So we can see here how much variance in the regression is explained by the variables. So in this case 46.1% can be explained, and the residual row is telling us the amount that is not explained. So this is just summarizing that again, and this p-value will be similar and these values will be similar to this table because we only have the one model. If we had more than one model, we would start to see some differences here. And then if we move on to our coefficients table here, this can give us more of a breakdown for how the data, how each individual variable is actually affecting our dependent variable. So what we can see here is that actually gestation makes the biggest contribution here at 0.46, and that is a significant effect. And then also we have the next biggest, which is 0.357. This is the length of the baby at birth, and again this is also significant, whereas all the other variables, they are not significant. The values here in this column, unstandardized B, so these represent actual units of increase here. So for example, if we look at gestational age, what this is telling us is that for a 1 unit increase, so for a week increase in gestational age, this will result in an increase of 0.231 pounds in weight for the baby. And we can see from this value that this is a positive relationship. So as one increases, the other increases. So I hope that that's been useful for you just to see how you can perform a linear regression using SPSS.